Okay, we're 1 minute in, and I think we're going to start. Thank you so much for coming so early. Hope you had a good time at the party last night and didn't get too stuck in the rain. My name's Patrick Courtney. I'm a member of the board of directors of SiLA. I've got a number of colleagues here who are going to be talking alongside. So we'll try and give you a rich experience of what SiLA is, what AnIML is, what we're doing, and what's happened in the recent past. We've got a booth downstairs, 2628. Hopefully you've had a chance to see us. If not, please drop by. We've got some goodies there, but let me start with this then. Just very quickly, SiLA is an international organization. We're a non-profit. We grew out of Roche and Novartis in Basel, Switzerland. We're very happy to be here in the US. This is a hugely important event for us. We've got a global footprint. We were founded in 2008, and we release a standard, which is this. This is the book. It's actually online and electronic and updated all the time. But to make a standard tangible, we print out the book. We develop the standard. That's what we do. We have a community of programmers. We've got about 4,000 members who write code that implements the standard. I'll explain a little bit about what that is in a moment. We also work with an organization called AnIML, Analytical Markup Language, to give the tools for interoperability in the lab. So all those wonderful devices in the lab can work together. And we get the data, and we get the protocols done correctly. And then we have a nice time in the lab rather than a frustrating time, which unfortunately is still sometimes the case. We're a non-profit. The code that is available is free of charge, so it's open source. There are no license and no royalties. So this morning I'm going to talk a little bit about what SiLA's done, what's new here. I'll hand over to Burkhart, who'll tell us a bit about AnIML, and then the bulk of this morning will be 4 showcases from some of our SiLA members, SiLA users, who are doing some really exciting stuff, and they can tell that to you much better than I can. So, as I said, SiLA, it brings together lab users, lab vendors, lab integrators, and a bit more recently we've realized that academics are hugely important. They develop new talent, and they also bring in new ideas, and startups find this very useful as well because they want to focus on their core technology. They don't want to be bothered too much with interfaces if there's already something available. And we try and align the interests of these 3 to 5 groups. And it's a challenge because everybody comes from different places, different disciplines, chemistry, biology, engineering, informatics. It's a big, big world, but it's really exciting and we're making great headway. So in the old days of yesterday, it was proprietary interfaces, proprietary data formats. You pay your money, you get something that works great for that box. But it's expensive to integrate, it's frustrating, and the total cost of ownership is high. The world with SiLA and AnIML is open communication protocols, open data formats, cheaper to use, reuse tools to collaborate within your team, within your organization, and across the world in collaborations, which is becoming more and more important. We also leans into AI techniques that need quality data, and it leans into fair data, open science principles, so that we can share data and not have to redo the experiment and lose time and energy. In terms of the technicalities, SiLA has got 3 parts. There is a core part, which is the functions and the capability of the communication system. There's a mapping to some specific examples, and then there's some part that links to the features. I won't go into this in detail. If you want lots of detail, we can talk to you at the booth. But to say that we have the governance process, we're not a standards body like ASTM, ISO. We're an industry standard, so we're driven by the users, we're driven by the community. So you need to tell us, join us and tell us what you need. And the code right now is available in, I think, 4 language bindings, Java, Python, and a couple of variants of C. So that's very quickly what SiLA is. I'm going to hand over to Burkhart, who'll tell us a little bit about AnIML, an update on that.
Thanks, Patrick. So my name is Burkhart Schäfer. I'm on the SiLA board together with Patrick and a couple of others here. I also run the AnIML task group at ASTM in the E1315 subcommittee on analytical data, and want to share an update of what's been going on in the AnIML community over the past couple of months. So one thing that we've seen is it's great to have a standards body such as ASTM come out with an analytical data format like AnIML, but what we also need is we need a proper forum for the users to meet, to exchange. And well, we feel that a strong standards community needs a strong roof. And so we've got the contributions of ASTM on the lifecycle management of the standard, and now we're putting in place a new AnIML user group. And we're just launching that right now. And it's intended to enable the community so that there are exchanges of best practices, events, and such. And it's intended to help organizations through their life cycle of adoption of standards. And we feel that there are kind of 3 stages through which you go. So in the beginning, you're on the interest stage, at the bottom of the curve. So you're curious, you want to find out more, and then at some point in time you decide, oh, this makes sense for me, I'm going to adopt it. And after that, after you've used it for a while, you figure out, okay, this could be strategic for my organization, and I want to make sure that the standards do well and that they keep getting maintained and so on. So you switch into contribution mode. Yeah? So you actively participate and you try to make sure that the standards can thrive. And those are the 3 stages that we see the organizations go through that are part of this community. And at each stage, people need different resources, which is what we're providing through the AnIML user group. So in the interest stage, we make sure that there is all the information that people need in order to embrace the standard. So success stories, blueprints for use cases, also user meetings to exchange with others who have done it before. We participate in industry events such as this one and others, and maintain resources on the web. Then in the second stage, if you say, oh, we want to adopt, then we help facilitate the usage of the standard. So for that, there will be trainings, examples and best practices, and hackathons and organized interoperability testing opportunities. And we're doing all of that in close alignment with SiLA. And for example, this week on Thursday, there is one of those events, which we call the SiLA Splash, that Patrick will be talking about in a minute, which is an all-day event that you might be interested in. And then in stage 3, contribution, we manage the roadmap and the execution for the continuous development of the standard and making it applicable to additional instrument types. And for those, we have working groups in place. And the idea is that we also put together a set of consolidated requirements so the vendor community knows what it is that the users need. And they don't have to talk to each user individually, but there is a consolidated set, which will help drive adoption as well. So this is one of the things that I wanted to highlight. Another one is a wonderful success story of where AnIML is getting used. So in the bioanalytical community, there is now a new initiative, well, not a new initiative, it's actually already 2 years old, which is called SOFT, stands for Secure Open File Transfer, for LCMS in bioanalytics. And that's supported by a number of folks, started at the European Bioanalysis Forum. It's also supported by AAPS, the American Association for Pharmaceutical Sciences, and has been implemented by Thermo Fisher, by Shimadzu, by Splashlake, and is actually deployed at customer sites already. And that's a wonderful success story. It's an AnIML-based bidirectional interface between LIMS and LCMS instrument software, so that there is an improved data integrity. As you know, AnIML has digital signatures, so you can actually sign the content. So when the LIMS sends a sample list down to the instrument, it digitally signs that, and that way the instrument can verify, is it actually the original list that came down? It can then do the analysis, and then work out the data, process the data, and when the data gets reported back to LIMS, again, it carries a digital signature, this time by the instrument software. And when the data flows back, the LIMS can ingest the data, and there is a guarantee that the data cannot have been modified since it left the instrument. So it's full circle, and we find that that's wonderful, especially since we have wonderful vendor adoption here. So that's a bit of an update on the AnIML side, and I'll hand it back to Patrick.
Yeah, thanks, Burkhard. So as you see, SiLA and AnIML work closely together because we bring complementary things. SiLA around the communication and the broker, and AnIML around the data side, which can only get more important as we go forward. So let me say a little bit about SiLA in terms of the structure and the organization and the activities we have. So we have a user conference, we have working groups, we have training, we have hackathons. Let me say a little bit more about that. So SiLA is code. It's a bit complicated. Some people dive right in and it works fine for them. Other people stumble a little bit. So what we've done is we've created some training videos. These are being updated all the time, but for those 4 language bindings, if you're a programmer, if you have colleagues who are programmers, that's the place to go. We have a YouTube channel and it's all there. If there's things missing, ask us. It's people behind the name. We've been running hackathons. We were lucky to have some funding last year to run a number of events in Europe. This is photos from the one we ran in Germany in a lovely villa by the lake in Constance with our partners BioLargo and DIH Hero, bringing 2 robots together, 30 people, I don't know how many pizzas, working till God knows what time. So fantastic experience. And we will do some more of these. We've got plans to do them at events. As Burkhart said, there's one on Thursday. And we want to do more in the US. So please ask us if you want it in Boston, if you want it in San Francisco, if you want it in San Diego, ask us and we can come together and make it happen. This is very important for us. The working group, so the work of the standards body of the organization takes place in calls every couple of weeks. We have a core working group which is run by our CTO, Daniel Euclid, and we've now on number 209. That's how long we've been running this thing. Very productive, very friendly, about 15, 20 people, fewer in the summer, more in the winter, very productive meetings, ask questions, make demands, and contribute. The last year or so, we've created 2 new working groups because this thing has grown and people have become more, ask more questions. We've had one member company, Takeda, has joined us. They're on the board alongside Roche, Novartis, Unilever, and Novo Nordisk. They want to do more about robots. And robots is not for everybody, but robots are moving into the lab, mobile robots, plate handling robots, all the different robots. And we're already 19 meetings into that and have a subgroup on labware. So the labware, the great SPS plate, is standard, but all the data around it is not. So there's a working group around that and developing new aspects. And just more recently, at the start of the year, we've created a new working group. I'm going to ask Tim here to stand up because he's the one who's leading it. So Tim, tell us a little bit about the adoption working group. Yeah.
Perfect. So I'm Tim from the University Medical Center in Göttingen. And during the pandemic, we've been running a couple of workshops on academic use cases where we're having a closer look on what is hampering the introduction of automation into academic labs. And the obvious outcomes was at first budget, of course. And here, I think with SiLA, we are set up pretty neatly because we've got such a big community and we've got a lot of open source code, open source programs, which are ready to be used for servers and for clients. So, because at the end users, the labs, they don't care about SiLA implementing SiLA, but they care about implementing automation. And then the second problem or hurdle was that many labs, they are lacking the in-house expertise to implement automation. And I mean, for many here are IT guys, so it's not a big problem to download code from the Git and compile it and configure it, get it running. But for many of my colleagues who are like medical doctors or biologists, it's not so easy, and we figured that many labs have the same problem. So we thought about how to overcome this hurdle, and this is why we founded now it's called Implementations Work Group, where we tried to find ways. And do we have another slide on the? Yeah, and for example, the first project we are working on is to have a SiLA installer, which is kind of being a front end for configuration and for downloading programs from the GitLabs. So you can get pre-compiled core components from the SiLA Awesome list and have them installed, and also connect to cloud services, and just to make the hurdle just as easy as when you try any software, you just download it, install it, and you can try and play around with it and get an idea of it. And this is what we want to get SiLA to. So, thanks.
It's a lower barrier to entry, get people started to use it and learn and benefit. So as Burkhart already mentioned, on Thursday we're doing a SiLA Splash, which is a bit hackathon, a bit training, and a bit networking. It's off-site. You need to register. There's a barcode, and there's some flyers back here. Encourage you to join that if you're available on the Thursday. You get to meet some more people and learn some more things. And then last thing about SiLA, we develop the standard. We work on the standard. It's a very technical activity a lot of the time. But we're also a business network. We also see members come together. They do business. They generate money. We as a non-profit take no share in that. We're delighted when that happens because that is success. We're also partnering up with more and more organizations. So delighted to be at SLAS. There's the Future Labs, US and Europe, Lab of the Future, Drug Discovery World. You'll recognize some other names there and names that are actually down on the floor. We work in partnership. We cannot do this on our own. We bring something, they bring something. So you'll see SiLA events and SiLA content at these events. But we also offer discounts for access. Some of these events are not free. And also an opportunity to come on the stage, as the showcase talks in a moment will show, come on, talk to the audience, interact, network. That's big for us. We have a T-shirt down at our booth. Do come and pick one up if you're anywhere between S and XL. If not, we will find you a T-shirt. And now the showcases. So you'll hear from Burkhard again in a minute with a different hat. Burkhard from Splashlake, Tim Fallon, where is he? From UCSD locally, Ivan from Promega, and we'll close with Richard from Labforward, and I'm going to give him enough time to do his piece very, very quickly. Let's do that. So any questions, anything that I skipped or you didn't understand before we go into the showcase? That's great. I was super clear then. I can't believe it. Okay, Burkhard, I'll hand over to you.
Thanks again, Patrick. Okay, switching hats now. This is my day job, and I wanted to talk a little bit about it from the other side, because obviously it's nice if you have a standards body and we create standards that people should be using. But then let's take a vendor perspective of why it makes sense to actually adopt it, and I want to talk a little bit about what that journey was for us, and how we're using SiLA and how we're using AnIML. And in particular, we're using that for fair data management and instrument integration, and I want to talk about that a little bit. So the way we see instrument integration at Splashlake is that you're looking for a full circle type of thing. And so you would start with the limbs, and in the limbs you've got a test request that the user creates, so they create the sample, and then what we do is we use SiLA to provide the limbs work list to the instrument, so it can pre-configure the instrument, and as you walk up to it, it has everything set up. Then you execute the run on the instrument, and at that point, the instrument provides an output file. And given that we live in reality, most instruments don't yet produce a nice AnIML formatted XML document. So this will be a traditional proprietary output file, which we can then go and take, and through our set of off-the-shelf converters, we can take that and translate that into the AnIML format. And so now I have both the conventional output file and I have an AnIML companion file, and both of these are valuable, right? So I want to preserve both of these because I can do interesting stuff with those. So what we do then is we put that into a file repository, which is basically a data lake with some additional functionality. And we also have a rules engine through which you can then process that. So you can define rules, which content to extract and which content is relevant to the downstream consumption. And those rules can be built graphically, and I'll show you how. And then those result values come back and are attached to the test request. So that way you've got the full circle loop from the limbs through the instrument back with the results into limbs. And since the test request also has enough identifiers associated with it, we have a pointer to the file repository where we have the actual payload content. And we have an AnIML viewer component that you can embed into any limbs application. And so you can actually get to see your chromatograms, your plate reads, and so on directly within the LIMS UI. And we find that that's pretty useful because it means you can actually look at the actual instrument data while you are reviewing your result in LIMS, which is a much tighter loop and which is much more visual. And this is what that looks like. So in this case, we've got a commercial LIMS. Some of you will recognize. And so what we do here, in this case in LabVantage, you've got your result entry screen, and as you navigate through the result fields, what we have here at the bottom is we've got a new tab which features our plugin, so you can actually see the instrument data in there, whatever is in there. And AnIML is one of the formats that we proudly support because we believe that is making our lives as a vendor easier to deliver these types of integrations. It facilitates ease of integration, and we have to deal less with proprietary vendor formats, and we encourage our colleagues in the vendor community to do the same. So that's the visual part. And then from the result ingestion part, I said we're taking this through the rules engine. And a rules engine, in ETL pipelines, they sound sort of complicated. And we've made that graphical. So you can actually configure a set of rules graphically. You can apply that to a couple of example files. And then you see, okay, these are the matches that I'm getting for that file. This is what the data looks like. So you can anticipate, this is how it maps to my result parameters in my LIMS and my ELN. And so you can actually configure an integration of an instrument in less than an hour and have full visibility of the content directly in the LIMS UI. And that's pretty cool. And that's where standards can really help facilitate integration and additional downstream usage. Now that you have your data in LIMS, what you've also done is you've generated these artifacts in a file repository. So why not kill two birds with one stone and say, oh, we're also going to use that same capability for data management. And we've all been talking about FAIR and so on. And at Splashlake, we think about, well, how do we give that concept of FAIR into the hands of a user? Because only if you give it into the hands of the user, can it actually bear fruit. And this is how we do it. So on the one hand, you've got that deep integration kind of thing, where you've got the repository with data harmonization, you've got the rules engine for the seamless data flow, this end-to-end instrument integration, and the viewer capability inside your LIMS and ELN, which are basically the building blocks for an enterprise solution. These things obviously take time to roll out, as with any enterprise lab informatics project. And so we've got a second pillar, which allows us to go broad rather than deep. And that means I can roll out a digital capability to an entire organization within a day. And the way this works is Splashlake makes Microsoft 365 science aware. And we're a certified Microsoft Cloud partner to actually deliver that capability. And what does that mean? It means you can use SharePoint and OneDrive for your instrument data, and it understands it. And you can use Power Automate and Power BI to do anything with your instrument values that they are producing, and you don't need a data scientist to do that. And all of the viewing capabilities suddenly appear everywhere in Office 365. And that is a wonderful way to roll out standardization to an entire organization, and it's a quick win for digitization. So we think that those two pillars can actually support each other quite well. And we want ubiquitous data accessibility, and we get that with the breadth, and we want the integration, and that is when we go deep. And so this is what our viewer looks like, which includes full animal support. It has visualization for over 15 measurement techniques, and you can embed it into other applications, which is exactly what we do with LIMS, and this is the same thing we do with Office. And the storage part is pluggable. So we don't want to own your data. You can use the repository that you want. You can use your S3 bucket. You can use your SDMS, and we just reach into it. And SharePoint is yet another storage destination for us. And so it works across measurement techniques. You just saw a little bit of formulation data. This is more on the spectroscopy side, or if you're into chromatography. And all of those measurement techniques are visualized the way they're supposed to, so that a scientist will happily accept that as a good alternative of seeing their instrument data without having to walk to their instrument PC. And to deliver that capability across an organization wherever you have a PC. And if you put that into Office 365, well, you've got your SharePoint here. And so in addition to just having your file name column, well, you also get a column with all of the data that you've extracted. So, I've got my sample ID here. I've got my barcode. I've got my result concentration and all of that. And if I click on that in here, it opens that data right there in SharePoint, which is actually quite cool. And then that means you can search. So wherever you have a search bar in Office, it'll find that stuff. Or you can build your dashboards in Power BI with KPIs and instrument utilization stats and so on, and build those scientific dashboards, all without the help of a full data scientist. And yes, we support Power Query, so all of that data can be queried and fed into spreadsheets, so you can democratize access to that. Don't worry, the spreadsheet doesn't contain the data. It's just a window into our structured backend. Yeah, and that's how we use SiLA and AnIML to deliver a capability that is otherwise simply very hard to achieve. And that's why we encourage our colleagues in the vendor community to do the same. So, thanks.
Okay, thank you, Burkhard. Any questions on that? Quick question as Tim comes in. Okay, hand over now to Fallon.
Great, thanks so much. Good morning, everyone. My name is Tim Fallon. I'm a postdoctoral fellow here in San Diego at the University of California, San Diego. And here I'll be telling you about some of the work we're doing to actually build our own integrated robotic arm work cells, and SiLA is a key part of the software to drive those work cells. So to start, you may have seen on the title slide, I'm actually from the Scripps Institution of Oceanography, which is a small sort of department of the University of California, San Diego. And you might be wondering, what is the Institution of Oceanography doing with lab automation and specifically with SiLA? So from a very broad perspective, the ocean is the largest ecosystem on Earth, and it has a lot of great uses. So in the intersection between biotechnology and biomedicine, we sort of have drug discovery. In the intersection between biotechnology and the environment, we can do gene discovery. So like all those thermostable enzymes that come from deep sea vents, like that is an ocean product. And then we also have toxins that are in the ocean that are an ongoing problem. So lots of, I think, interesting big questions that are happening around the ocean. So how do we actually answer these ocean-sized questions? One, you have to just get there. So Scripps is very unique in that it actually has ocean-going capabilities through large research vessels. And then the other side of things is we think we need to think big, and that means thinking big experimentally, and that means applying robotics and automation for our experiments. So within the past couple of years, we actually applied for a grant from Illumina, who's a big local biotech here in San Diego, to try and enhance our training program in laboratory automation, because there's actually not really much university-level training in laboratory automation. I think if you're working in it, in industry, you probably learned on the job. So we're trying to think about how we can actually change that. So Illumina was very generous. They donated quite a bit of automation equipment and also funding to try and develop this program. So some of the goals of the program are actually to develop a graduate course in the practical use of laboratory automation. So this is kind of from the angle of like workforce development. That's why Illumina is really interested in it, as UC San Diego is sort of the major local university. They hire a lot of students out of the university, so we just want to have that kind of enhancing our educational programs. And then we also want to use the automation to support our research programs in oceans and human health research. And to do this, we're building a couple pilot work cells, one for synthetic biology, broadly stated, which is plate reader-based assays, and one for high-content imaging. And yeah, there was a QR code if you're interested. I'm happy to talk more about it. So how to actually integrate your lab instruments into robotic work cells. So I imagine most people are probably familiar with the concept of a work cell, which is a bunch of laboratory instruments which are accessible from a robotic arm. So it's instruments plus robotic arm plus the tables to sort of support them. But it's complex to build these work cells, right? Like there's a physical system. So how are they designed? Is CAD going to be involved? And how do you actually assemble them is also a major problem. And then the software to actually run them is also quite complex. So you've got to execute protocols on them, and you've got to handle data from them. So yeah, lots of challenges, I would say. So there's two strategies, right? You can build it, or you can buy it. This is a common, I guess, dichotomy that happens in industry. On the buying side of things, there's these system integrator companies. So taking a local example of Biosero, they're a great company. But at least from an academic perspective, it is high cost. Biosero can do any type of complex laboratory automation that you want them to do, so they essentially have unlimited complexity, and they're going to be fast, but high cost for academics. So on the build side of things, if you have in-house hardware and software expertise, so in our case, that's just me, you can be low cost, although I'm not free and the instruments are expensive, and I don't think anything around laboratory automation is really low cost per se, but it's low cost in comparison to, I think, the full service kind of solutions. The complexity is limited, right, because I don't know the full breadth of what a company like Biosero would know, and it can be slow to fast depending on how much I have to learn to make it all work. So where does SiLA come into this? So if you're going to be communicating to your instruments in a work cell, the kind of, since I guess the early 2000s, the standard that people have been using is serial communication, so RS-232. So on the left-hand side of the screen, what you can see is actually You can buy this. This is a real product on Amazon. You can get 16 serial ports out of a single PCI card. So you can imagine you can connect to all your instruments using these serial ports. But that's not great flexibility, right? Those cables aren't very long, so I don't know how you're going to be able to do that. And actually, there's a lot of reliability problems with serial. It's just kind of a noisy physical protocol. So what's the modern way, 20, 30 years on? I think it's SiLA 2. You can use it over the network or Wi-Fi, so it gives you flexibility and it gives you reliability. So SiLA, a big part of it is kind of considering it from the perspective of like instrument drivers. It can do more than that, but that's sort of how the important part of SiLA for our synthetic biology work cell. So what I'm showing here on the left is actually a photo of our pilot work cell that we sort of built out. In order to convert RS-232, which is kind of on most of the instruments, into SiLA, there's this concept of using gateway modules, which are like little computers that will sit next to your instrument that'll sort of handle that interchange. And then there's a great paper here that sort of describes that concept. But what do we have for actual availability for SiLA 2 drivers at the moment? So we've got 5, I guess, instruments on the work cell. We can swap out the plate hotel, so we've got sort of 2 alternatives there. The key thing is going to be the robotic arm. So currently there isn't a SiLA 2 driver for the robotic arm. This is the KX2 from Peak Robotics. But the SiLA robotics working group is actually making really quick progress on developing SiLA drivers for, or just making it much more feasible to sort of develop your own SiLA drivers for robotic arms. We have an OpenTrons liquid handler on this work cell. It does have a SiLA driver. We actually have a TCAN Spark multi-mode plate reader, and this is really nice because TCAN is one of the, I think, leading vendors in sort of the SiLA space, and they provide a driver. And then the plate hotels are sort of another stumbling block, perhaps. But I think the important thing is that the progress is there, and the cost is quite good, right? It's essentially free for these sort of things if you have open source versions of these drivers. And I should mention that these SiLA 2 drivers are probably available from a lot of vendors. We're just sort of going the route of trying to develop our own because it gives us more flexibility. Okay, great. So how do you actually schedule and execute on your SiLA 2 work cell? So if you go with a company like Biosero, they have their Green Button Go product, which is a dynamic scheduler. From our DIY work cell perspective, you can just use Python to actually drive the SiLA commands. If you want to go like a low-code approach, you could use something like Node-RED. And then actually one of our collaborators, Dr. Mark Dorr at the University of Greifswald in Germany, he's actually developing a dynamic open source-based SiLA 2 scheduler. So you could email Mark if you wanted to know more about that. But it is in development, academic product, so long timeline, perhaps. All right, so I think the future is sort of how do we make these modular and interoperable DIY-friendly automation systems. So it starts with SiLA, that gives us the communication to the instrument, so big X over lots of serial communication. You also need to execute protocols on the instrument, so one option is the LARA suite, which I just mentioned, or you can do it directly from Python. It's not very complex, but it gets the job done for simple protocols. And then I think an ongoing question is how to actually represent and share laboratory protocols. Like if you wanted to do AI/ML, like how would you actually have an AI large language model like generating a protocol that could be run? I'm actually involved in a project called LabOp, which is trying to make this work. So if you're interested in that, I'd be happy to talk more. So that's all I have. Thanks for your attention, and I'd be happy to take any questions.
From Promega. All right. There you go. Okay, Ivan, you're on.
Hi, everyone. Good morning, and welcome to our presentation. My name is Ivan Ivanov, and I have a kind of a long and convoluted title, but it's Senior Software Instrumentation Product Owner for Promega. So basically, I kind of lead the instrumentation software
Keep going, keep going.
development. And sorry. In this presentation, I'll be talking about Promega mostly as an instrument vendor. Even though Promega has several products that are not instrument, I'll present Promega, talk a little bit about both sides of our business, and kind of focus on one particular product that we integrated with SiLA too. Promega, I don't know if you're familiar with Promega. Promega is a global company that's been around since the 70s. Basically the main product of Promega is a combination of reagents, biological reagents that help researchers perform their various tasks. We have probably several thousands of different reagents for various industries. Promega also designs instruments and integrated systems. So Promega supports various different types of industries, more or less all of them in the life sciences sector and biotech. But we support government and academic laboratories, research laboratories. We have products that help forensic and paternity laboratories, pharmaceutical and biotech industries, clinical molecular diagnostics, and also food and water safety testing. So like I said, two types of products, reagents, which I will not talk much about. Those are kits of chemistries that are used in various industries and situations. And we also design and manufacture and sell integrated systems. So those are different kinds of instruments that are highly tuned to work with our reagents, with our chemistries. That being said, many of those instruments are pretty open. So in other words, you can use them with your own chemistries, with your own reagents, as well as you can integrate our instruments in various other systems that combine many other types of instrumentation. So this is kind of the area that I'll focus mostly. So our instruments. Promega has designed during the years various types of instruments, mostly in the cell biology, molecular diagnostics kind of area, but also genomic research, and et cetera. So, like I said, we have a couple of different categories of instruments. We have our multi-mode plate readers, and that's the instrument that you can see on the far up left. We have a couple of different categories of readers. Mostly Promega readers are known for their bioluminescence sensitivity and wide dynamic range. They're really, really good in that. We also have fluorescence absorbance and other things, but those are kind of the flagship instruments. We also have various types of DNA purification systems, mostly magnetic-based, 1648 channels. We have integrated systems with various liquid handlers. We have dedicated luminometers. Here down in this area, you can see our new spectrum lines of instruments, which are actually capillary electrophoresis instruments, mostly at this point used in forensic and paternity labs. Those are fragment analyzers, essentially. Yeah, we have two flavors of those, a big high throughput one and a smaller, more kind of desktop one. So I'll talk mostly about our GLOMAX microplate readers because that's the instrument that we have integrated with SiLA. The need for that was really because our instrument's been used in many different environments, in with different companies, and there's always need to integrate this instrument with workcells, robotic stations, liquid handlers, other systems. And when I say integrate, that means both integrating the instrument control aspect of this, but also the data aspect. So it's always been a challenge, like many before me said, it's always been a challenge to integrate our instruments with our different systems, because it always leads to some kind of a customization, custom made drivers specific to various vendors. So we kind of recognize this as a general problem in our instrumentation, and we, as a company, started supporting SiLA several years ago, actually more actively with SiLA 2 effort. But we have been SiLA members since probably 7-8 years ago, maybe even more. Talking about the instrument, like I said, it's a multi-mode reader that offers various reading technologies. It's highly optimized to work with our reagents. In other words, with our reagents, it will probably get the best results. But that being said, it's fairly open. You can use it in many other situations. It is the gold standard to luminescence performance. It's very, very highly sensitive instrument. We've designed it to be compliant with Part 11, CFR Part 11, which is the electronic records, electronic signatures that is quite often required by our customers. It is one of our automation-friendly instruments, meaning that both from software and hardware perspective, it can be integrated in various other systems. We have instruments that are not that automation-friendly, but this is one of our most automation-friendly instruments. And most importantly, it has built-in SiLA support for automation integration. So talk a little bit about the SiLA support that we have implemented in this instrument. We have designed and built in SiLA server in our install. So the SiLA server comes by default. When you purchase the instrument and software, the SiLA server comes by default. It is not enabled by default, but you can enable it fairly easily. And it is based, actually, we have collaborated with TCAN, and it's based on the TCAN open source SDK. It's fairly easy to integrate and put to work almost immediately. And to support our customers, we have developed also some additional tools and features. So basically, we have developed a sample SiLA client implementation, which includes full source code, includes manuals, a separate application that actually can consume your SiLA server, but you can also use to develop your own other, your own custom software. Currently, the sample source is C#.NET only. We're looking at implementing additional Python, probably will be the next one that we're going to implement. And of course, it comes with documentation. So basically, that is right now the only instrument that is fully SiLA supported. We're looking at, we have 2 new upcoming instruments that we will be implementing SiLA as well. And as interest goes, we can implement SiLA with our other instruments. I mean, we have created the basis for it, so it's fairly easy for us to add more instruments in our ecosystem. This is really what I wanted to talk about and welcome any questions.
Thanks, Ivan. Okay. So now for our last one, I invite Richard to come up. I'm going to find the talk. Where is it? There we go. Okay.
So, hello everyone. My name is Richard Watson. I am the head of lab transformation at Labforward. Just a bit of my background. I am my previous life, I was a research laboratory manager at the University of Pennsylvania and at Children's Hospital, working primarily in cell and gene therapy laboratories. So today I'm going to tell you about my experience building this test case in the House of Life Sciences in Switzerland with some of our colleagues from TCAN. So just to reiterate from yesterday's talk between Dennis, my Director of Marketing, and Marco from TCAN, that TCAN and Labforward, we are committed to establish an open digital ecosystem, and this is for the benefit of the end user. All right, so we have this shared vision around connectivity, and we realize that we need to work with other folks to figure out this integration puzzle. And this use case we have here is the House of Life Sciences in Switzerland. So what you're seeing here is a schematic for a high throughput protein normalization assay. What you have, we have a scanner for when a sample comes into the laboratory. It's then transferred to a freezer for storage. At some point, it is then taken to an incubator for expansion, plated onto a 96-flow plate using the TCAN liquid handler, and then read on the TCAN Spark reader. You'll see some different lines here instructing you, the legend. We have a physical sample flow, sample data flow, a device orchestration layer, introspect, and a metadata layer, which I will walk through right now. Okay. So, as I said, the sample comes into the laboratory, makes its way to these different work areas, the different 6 work areas, -80 freezer, incubator, fluent, and the Spark. And at each step, we are collecting data and feeding that into our lab operator system. So this is the data sample flow. It's scanned into Lab Register, which is our inventory management system. That data is then fed into Lab Operator, which is our laboratory execution system. At the point where it makes its way to the Fluent, we add a well ID to that sample record, in addition to the sample ID. That's also then fed back into Lab Operator. When it makes its way to the Fluent, the Spark, we add the concentration to that sample record, and that's sent back over to Lab Operator, and then that file is fed into the Fluent in order to do the normalization based on the concentration we received from the Spark. So on top of all of that, what's happening, we have this additional layer where we're collecting metadata and introspect data. At the first station here where the sample comes into the laboratory, we have sensors placed throughout the laboratory to pull in environmental data such as temperature, humidity, light, and atmospheric pressure. At the second station here, which is our -80 freezer, we have another sensor attached to that which allows us to measure the temperature. If there are any inconsistencies or if the freezer goes out of a set parameter, we get an alert for that. Similar situation in number 3 here by the incubator. We have another probe that covers CO2, humidity, and temperature. Again, if the equipment itself goes out of a particular range, we get alerted with that. Step 4, we are actually pulling data via the Introspect software for equipment status and some additional parameters as well for the Spark reader. So this is all possible because of the SiLA drivers that TCAN made available to us. We're able to use those drivers in our equipment orchestration layer in order to tell the Fluent to start, to stop, as well as the Spark, and to use that file that's generated by the Spark to do the normalization run on the TCAN fluid. So now I'm going to pass this over to Jason from TCAN to kind of go more into some of the details behind the SiLA drivers.
Good morning, everyone. Great to be here. Thanks for coming here so early as well. Just a couple of items that TCAN's contributed here. First is the SiLA 2 server for the fluent control. This we actually put into open source to encourage the community to enhance it where needed. And this really enables the not just the lab operator to access the data and control the fluent, but also other softwares, as we've heard today. Fluent control also sends data into Introspect, which is our usage tracking software. We've already heard a couple of mentions today of the SiLA server for Spark control. So this again enables control. One of the great things about the SiLA protocol is it's distributed, so it can be run on a separate computer. The Spark control with the imaging module does require a separate computer, and it's great to see other aggregations happening that I wasn't even aware of. Also, to help the community, TCAN's dived into open source. So the first item was a SDK to enable others in the community to create SiLA 2 servers. Ivan already used this, and there's a poster on that. We've seen also with Labforward, this really accelerates the integration compared to the proprietary methods, going from a couple of weeks to several hours. Once you've integrated one SiLA device, it's very little cost to integrate further SiLA devices, so really living up to the claim of rapid integration. And the last piece, okay, there's one more slide, sorry, which is the SiLA 2 Python server. So with the SiLA server, this can also be accessed using other languages such as Python. And I think we've got some time for any questions. Great. I'm back to.
You're so clear. You're both so clear that no questions. I've got one actually on House of Lab Science. That has also got quite an interesting story. So can you say something about it?
Yeah. So. House of Lab Science is I don't know the best way to describe it. It's basically lab space in Hombrechtikon, which is actually the village in Switzerland where TCAN was founded, where I started working for TCAN a long time ago. And they've built up lab space to enable companies basically to rent lab space and all of the infrastructure around it. If you Google it, you'll find it. But it's a pretty smart place.
Lab co-working space, incubator.
Yeah, so imagine co-working space, but laboratory.
Feeding into the SiLA philosophy of openness, exchange, open science.
Yeah.
Good. Thank you.
So for the use of that in lab space, what is in what physical or where is the user interface basically displaying? Is still in local pieces? Can it also be on a portable device, for example?
Richard.
Yeah, it's can be both. So it really depends on what that user wants to do. With our software, it's all web-based remotely. If you're comfortable working with web-based as a fluent, what the Spark can, all transportation or happens in capacity, working
Through the situation.
exactly. Try to be as close as possible. Exactly.
Hello, I'm Brendan from Genentech Roche. Thanks very much for putting this together. I think this is, I hope this is the future of how we interoperate with our instruments. My question for TCAN, is there anything in the API you haven't implemented in SiLA 2? And just can you talk, have you implemented like a governance process?
Yeah, so the native API of Fluent Control does have some additional functions that we've not yet exposed in SiLA.
Can you talk briefly about how you thought about that? How are you thinking about
So really, we took a minimum viable product approach, as is common in the agile world, and this is a first iteration, so we put in a core set of functionality. It's in open source, so if somebody did want to extend it, they're welcome to do it, or we could do it if there was also a request.
Can I push on that a little bit? Is your API open? Like if I wanted to hire a programmer to extend the SiLA 2, can I do that for TCAN?
Yes, the API is part of the product.
Okay, awesome. Thank you.
We really want to take out all of the barriers to integration. It's a strong philosophy we believe in.
So we know each other already, but I'm Matthew Keegan and I work for Automata, a lab automation company. We're really interested in this topic. We can definitely see the benefit. We have to write a lot of drivers as it is, very custom ones to integrate with products that are out there. The challenge we've had is getting more adoption. TCAN have really paved the way as one of the biggest interim providers doing this. How do we, as a group, and also as an industry, encourage others to see the value of moving to SiLA?
So I think Tim has started a work group on adoption to reduce the barriers, events like this, publishing, making it clear that, you know, when we have an integration, SiLA is inside. And I think also, you know, we do integration, you do integrations, you know, we work with many third-party suppliers, you know, also just requesting them that, you know, any future development is based using SiLA 2. I mean, it's unlikely that a vendor will change their interface for an existing product, but really to make sure future development, give that feedback to the vendors.
Thanks, we'll support you on that.
I have one additional comment to that, to your question. I think you know, companies like Automata and Labforward, you know, we're the ones being in that interface between the equipment manufacturers and the end users. I think really communicating as best we can to the manufacturers that this is what the end users want. I personally, from my experience with Labforward, have had customers that did not go with a particular manufacturer because they did not have a SiLA driver, and integration was very difficult for them. They didn't want to deal with the additional time and costs that would take to develop a specific driver for this device, so they went with a different platform. So I think this will keep happening more and more and more, and if we communicate this to the manufacturers to say, listen, you want to come on board, you want to be a part of this, and this is going to give you access to the end users.
Just, I concur on that. So I'm from Novo Nordisk, and and I control the budget. So I go to manufacturers and I say, I will buy your equipment if there is a SiLA driver, and if you don't have it, I'll look at someone else's. So I think that's the way we're going to make this happen with money. So
yeah.
if you're behind that, ask for it. That's it. I think.
Yeah, and just to add to that, within SiLA, we've strengthened our board now with predominantly user companies, so the users really need to feel their power. The big companies, but also the small companies, the customer should decide. They need to feel their power and be in communication in a community. Okay, thank you all for coming. I think we've had a great set of talks. Come to see us in the booth 2628 and enjoy the rest of the day.